defined by the application document model, which is a logical model. However, the information objects are stored in a relational database. And this means that they are stored according to a different model, is the relational model. So basically, the application document model expresses the semantics, the structure of your objects in terms of entities, their properties, and relationships between them. And those have to be marked into the relational data model. That is in relations, tables, and their attributes. Now, a new requirement comes in. Now you have to export your information objects, your information space, or a part of it, to the OAI protocols. OAI protocols are standard protocols by the Open Archive Initiative, and I'm not going to spend many words on that because they are standard, they are very well known, so I bet you will know at least the best. You also have common ones. And the point here is that why you want to export your objects to OAI. For many reasons. For example, let's say that your institution wants to export the information objects, the metadata records to OAI image because it wants to be harvested by the European aggregator. Europeana is the European aggregator that collects cultural heritage material from all across Europe. So it's important to be there if you are a cultural heritage institution. Or maybe your institution wants to export packages of objects to the OAI protocol because it wants to join the web of data according to the linked principle. What would you do? So you have your own information system, and it's great because it's based on a relational database, and it's a very powerful technology. It's expressive, but it's general purpose. This means that there are no built-in tools for the OAI exports. You have to implement it yourself. So what happens? Happens that you will call a team of developers, you explain to them which part of your application document model you want to export, and the developer will implement it. And then you're happy. Maybe not. Maybe you're not so happy because there are some drawbacks. First, realization cost. Often institutions lack of an IT department, above all if they are small. Maintenance cost. So what happens when you change the application document model, or if you want to change the physical relational model because you want to optimize? What happens if you want to change the structure of the objects you want to export? This requires more coding, so more money. And last but not least, the time. Because we used to say in Italy that everything had to be done by yesterday. So you have never the time to do the things you want to do. You're always running, you're always in a rush. So these are the reasons why we realized Wiser. Wiser is a tool that puts down the cost and time for the realization of all OAI interfaces over relational databases and allows the configuration of the objects you're going to export. So basically, Wiser provides a wizard, a user interface that guides the user in the configuration of the export. And the user performs just 4 simple steps. First is the provision of information to connect to the database. Then the user has to provide feedback on the reconstruction of the document model that is done automatically, and we'll see afterwards the reason for this. Step 3 is the definition of the view. The view is the portion of the document model you want to export. And finally, the user can select the target protocol, so ORI, PNH, or both. First step, well, we have to tell Wiser where is the database. So host, port, database name, user, password, nothing esoteric. The second step is more interesting. The second first step is for the reconstruction of the graphical model. So basically, OISER now knows where the database is. It can connect to the database and get information about the schema. The information about the schema of the database is contained in the relation catalog, which is a special database which collects information about tables, the attributes, and indices and keys. So OISER reverse engineers the information in the relation catalog and creates a graph. So it reconstructs the document model. And to do this, he applies simple mapping so that for each relation it creates an entity, for each attribute it creates a property in the corresponding entity, and for each foreign key it creates a relationship between entities. And this is our result. Here you can see that OISER created a graph of entities and relationships. So article is an entity, it's fine. It's connected to many other entities. But there's a problem here, and it's clear. You can see it. Because article is an entity, file, well, okay, but uses sites. Doesn't really seem they are entities. And indeed, they are not. So why they end up like this? We end up like this because when you are dealing with an object model and a relational model, then you have some problems. And those problems are usually called impedance mismatch. So what happens is that when you have to model a many-to-many relationship into the relational model, you model it like a relation, like a table in the database. So that's why they count like entities here. And this is only one of the effects of the impedance mismatch. The impedance mismatch is the set of difficulties you have to deal with when you have to cope with when you're dealing with different modeling approaches. So here you have to tell OISER which entities are not entities. And you can do this by clicking on the entities. And then rectangles become rhombuses, which are the symbol in OISER for many relationships. So now you have the graph document model, and the user can work with it. And that's very important, because now we're going to define the structure of our packages in terms of this model, and not on the physical relational model. So OISER hides the complexity of dealing with the database and of writing the transformation code from database entries to XML records and the code to deploy UI endpoints. The user just works on the logical model. Now it's time for the user to define the view. So how your objects will look like when you're going to export them. A view is a tree with a root in the graph. It defines the structure of your packages, and you can give it a name. And this is an example of a view. So we selected the article as the root node, and then we follow the relationship described, which target the entity file. Then we follow the relationship sites, which target the entity data. Okay. Then the user can select the target protocol or the PMH role, and then click on export to view. And from this point on, the user is done. So now the system does everything he has to do to deploy the endpoint. The view is internally represented with, according to this grammar, which is a very simple grammar, nothing strange. And this is needed because OISER has to interpret the view. That is, it has to generate the SQL queries to create the packages for the export. So what it does is that for each view, which is a tree, it extracts each path from the root to a leaf node and generates the query. For example, in the view we saw before, we had two paths. P1, article describes file. P2 is article uses data. And these are the queries that Horizon generates. And generation is made through this algorithm, which is here just to scare you a little bit so you don't fall asleep. I'm not going into the details of it, but just say that we unfold the paths and we generate the select statement and the joins between tables that are needed to get information to construct our packages. So now we have the queries. We have to run it on the database and to run them. And this is a task of the xvid package generator, which executes the queries, stores the results in memory as double tree text structures. And two modes are available, materialization mode and only mode. In materialization mode, all the queries are run and all the trees are stored in memory. And they are ready to be delivered. While in the on-demand mode, we only execute the queries that are needed to generate the packages to serve the incoming request. So in materialization mode, the requests are served faster because you already have all the things you need in memory. So it's faster, you don't have to wait for yes, you have queries to run. On the other side, it can be a problem if you don't have enough space or if your database is huge. So you may often space with the other node, the on-demand one. At this point, we're almost in the end because we now have our trees in memory, but we have to serialize them in a format which is suitable for OAI, which basically is XML. By default, Wiser features its own format, which is Wiser, but you can plug in XSLTs, that is transformation from XML to XML, to deliver different formats. For example, there's a default XSLT from Wiser to W4, because W4, well, you have to deliver W4 records to be compliant to the PNH protocol, so that comes with it. So how does the serialization work? Why PNH? PNH features one main entity, let's say, which is the OAI item. So we create one item for each package, which is the level 3 we have in memory, which corresponds to an instance of the view we define. For the OAI identifier, we choose the primary key of the root, and we use the date of creation of the package as the date stamp. Finally, the metadata section, we use the OIZ format, which basically encodes nodes and the edges of the tree. This is an ongoing work. We are still implementing this. And in the first implementation, we are not going to provide support for sets and deleted brackets. So we have to still work a lot on this part of OIZ. But we did fully ORE. So ORE features three main entities: aggregation, aggregated resource, and proxy. So to keep it short, we create one ORE aggregation for each package, so for each tree, and we encode it in a resource map, of course, as ORE is asked. We use the primary key of the root as the aggregation identifier, and the aggregated resource aggregated by this aggregation are the objects in the tree, that is the nodes in the trees. But these nodes in the trees are linked with each other. There are links, there are relationships, and we encode these through the proxy entity of ORE. So, to sum up, the generation of OIA exports is a common requirement, it's very likely that we will have to implement it some way.